A car moves uphill at 40 kilometers per hour and then back downhill at 60 kilometers per hour. What is the average speed for the round trip? The first thing we would want to do is draw a picture depicting the scenario. We have the car driving uphill here in the black colored ink, and we've labeled that distance D, and then it drives downhill with the same distance. So notice we've also labeled that distance D as well. The speed going up the hill is 40 kilometers per hour. We've represented that as V with the subscript U for uphill, and then V sub D is the speed going downhill, which was stated to be 60 kilometers per hour. Now, let's consider the main question, which is average speed. So, of course, we want to think about what the equation for average speed is. Now, hopefully we know that the average speed of an object is defined to be the total distance, which we're just going to say is d total, divided by the total time. So we'll call that t total. So what we're going to need is two pieces of information. We're going to need the total distance that the car moves, as well as the total amount of time that it takes to do so. Now, the total distance can be represented relatively simply. We can see that the car goes uphill by a distance d and then goes downhill by that same distance d. So the total distance is going to be 2d. So that part of the problem is relatively straightforward. We're going to have 2d for the total distance. But when it comes to the total time, that's what makes this question somewhat challenging. So our task right now is to figure out the total amount of time that the car travels. Let's go back to the uphill scenario. Again, we have the distance d and the speed. We're going to be using an equation from kinematics. Now, this equation says x minus x0. That's just a fancy way of saying your final position minus your initial position. But we can simplify that by calling that the distance that the car travels. So that's going to be the distance d. And then going uphill, the initial velocity was the 40 kilometers per hour. So we'll just write 40 there. And then we're going to multiply that by the time required to go uphill. So we're going to call that t sub u. Now, continuing with the equation, we can assume in this case that the car is not accelerating. We can assume, in other words, that the car is traveling at a nice constant speed. It would have been nice, honestly, if it said it was traveling at a constant speed, but we're going to make that assumption because, frankly, if we don't, we wouldn't be able to solve this problem. So if it's traveling at a constant speed, that means the acceleration is 0, and this term right here would completely drop out. You would have 1/2 times 0 times time squared. So that would all become 0, and so we can omit that from the equation. So this would be the equation for the car traveling up the hill, but in a similar manner, we can represent the equation going down the hill. So we would have that distance d is equal to the initial speed of 60 kilometers per hour multiplied by the time required to go downhill, and then plus 0. Now, what we're going to do is we're going to solve for the times. So we're going to divide both sides of this first equation by the 40 kilometers per hour. That would cancel it out on the right-hand side. And then we can do something similar here to solve for the total amount of time going down the hill. Just divide both sides by 60 to cancel it out. So now we have these two times. Again, the t sub u is the time going up the hill, and the t sub d is the time going down the hill. But we want the total amount of time, so think about how you would get the total amount of time. And of course, all you would need to do is add the time going up the hill to the time going down the hill. So we would have the d over 40, and then add that to the d over 60. This will be the total amount of time that the car is traveling. We're going to take this expression for the total amount of time, and we're going to sub it in right here into our average speed equation. Why don't we scoot down the page to make a little more room? So there is our new and improved expression for the average speed. We just need to simplify this. Now, at first, it might seem that we can't calculate the average speed because we don't know the value of d, but as we will see momentarily, that's going to algebraically cancel out. Now, in the denominator here, we are adding two fractions, so we have to find a common denominator, and perhaps we can just make 120 the common denominator. So we're going to multiply this denominator by 3 as well as its numerator, and then multiply this denominator by 2 as well as its numerator, and that's going to give us a common denominator of 120. So in the denominator of this complex fraction, we're going to have 3d over the 120 plus the 2d over the 120. And then we have 2d up here. Now that we have the common denominator, we can add those fractions together. So we're going to end up with, let's see, 3d plus 2d is 5d, and that's all over 120. So far, so good. But again, we have a complex fraction. we'd like to simplify this. Why don't we multiply the denominator by 120 as well as the numerator? That's effective because then these will cancel out. And then in the numerator, we would multiply the 2d by 120. We're going to get 240d. This is now all over 5d. And there it is. The d's will algebraically cancel. And that leaves us with 240 divided by 5. We plug that into a calculator. We end up with 48. That is our average speed. And the speeds that we were plugging into the formula were in kilometers per hour, so this would also come out into kilometers per hour. That is the correct answer. Notice that the average speed is not simply the average of the original speeds. So just go back. This is actually a common mistake. Students would often take 40 plus 60 and then divide that by 2. So if you did that, you'd get 50 kilometers per hour. But that is not the correct way of analyzing the average speed. We can see we actually end up with 48 kilometers per hour as the correct answer.